What's this? It's a piece of paper, not a ball.
Excuse me? Are you Odele Coddington?
Yes, I am.
We found this equation in our school.
Let me take a look. Oh, this is a very well-known equation called the Clausius-Clapeyron equation.
Can you say that in 8th grade language?
Sure, I can give it a try. What it's actually describing is the dependency of saturation vapor pressure on temperature. To understand a little bit more about this famous equation, we have to understand the terms in the equation. It looks quite complicated, but there's actually a fairly basic explanation. Now in cloud formation, we're talking about the change of state from water in the vapor state to water in the liquid state. So what you're looking at here is that the change in the vapor pressure with respect to the change in temperature, the capital T, is proportional to that energy that's conserved in the process over the change in the volume between the vapor state and the liquid state.
So does dew point temperature have to do anything with this?
Yeah, it actually has a lot to do with dew point temperature. Let's take a look at some data here, talking about how our clouds are made and how they're formed, increasing temperature versus increasing vapor pressure. And you see a red line kind of dividing what I've titled unsaturated clear sky air versus supersaturated cloudy air. This red line here, that's a function of temperature and vapor pressure like we discussed already, is the saturation vapor pressure. Talked about clear sky. It's not really clear. It is condensed water vapor in there. Marked A tends to be what we would call clear sky. Now, if you were to move that parcel of air right along this way to the point B, right where it intersects with this saturation vapor pressure curve, that point B has a very special name called the dew point temperature. So if you have out on your patio a glass of cold water and then you start seeing condensation on the surface of the glass, that means that the surface of that glass has allowed water to condense on it at relative humidities less than 100%. That's the same process that happens in the atmosphere to form the clouds.
So what does this have to do with us, though?
Well, you're right. I mean, I'm not entirely sure, but this equation really kind of gives you general behavior for cloud formation.
So we should just go back and see if we can find it?
I think something more specific to give you an idea of what current conditions are.
Not another clue.
Thanks anyways. this place, go to the door that says roof. Okay. Wow. Descriptive.
Can we have some cake?
No! Not for you!
What are you doing? No! 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 Aaron! Why did you do that? That was cake!
Yeah, there
There's a whole huge